Let us understand how we can take care of hash partitioning of tables. It is primarily used to create partitions based upon modulus and remainder. What is modulus and what is remainder? We'll talk about those things at a later point in time. For now, let's focus on the syntax and semantics of hash partitioning. Here are the steps involved in creating table using hash partitioning strategy. We have to create table using partition by hash. We have to add default and reminder specific partitions based upon modulus. We need to validate by inserting data into the table. We'll first see how to create the table, then we'll actually talk about how to manage the partitions, and as part of that we'll also see how to insert the data into the table which is created using hash partitioning strategy. We can detach as well as drop the partitions from the table, or we can drop the partitions directly as well. Hash partitioning is typically done on sparse columns such as user ID. Sparse means it contains too many unique values. Examples of sparse columns are nothing but user ID, first name, last name, email ID, date. All these are sparse columns. There is also something called as dense columns, gender, month, which have only few distinct values. They are called as dense columns. Hash partitioning is typically used on sparse columns, not on the dense columns. For dense columns, we typically use list partitioning. If you want to use hash partitioning on more than one tables with common key, we typically partition all the tables using same key. That way the performance with respect to joins will improve quite a lot. Now let's get into the details about creating the partition tables using hash partitioning strategy. The table name will be users underscore hash underscore part. It contains same columns as users. We will partition the table based upon user ID field, which is nothing but primary key. We will create one partition for each reminder with modulus 8 as part of the next topic. In this topic, we will only see how to create the table, how to manage the partitions. We will see those details as part of the next topic. Now let's load the SQL magic, and also let's create environment variable called as database underscore URL. Let's drop users underscore hash underscore part if it already exists. And then you can review this command create table name, which is nothing but users underscore hash underscore part. You have user ID as serial field. I haven't specified primary key here, but the primary key is specified here. And then once the create table clause is done with all the column names and data types along with the primary key, now you can say partition by like this, and then you can specify hash because we are trying to create the table using hash partitioning strategy, and then you can specify the field on which you want to apply the hash partitioning. In this case, user ID is primary key, and hence we don't have to worry too much about using that as part of partition by clause. Keep in mind that if you are trying to partition a table with primary key, the partitioning key should be part of the primary key. In this case, user ID is primary key anyway, and hence we should be able to use as part of hash directly like this. However, if you want to use other columns such as email ID as hash partitioning key, then you have to include user email ID also as part of the primary key. Then only you will be able to apply partitioning strategy on top of email ID. So as we have the create table command ready to partition the table using user ID with a hash algorithm, we can run this command and it will take care of creating the table for us. Even though table is created successfully, we will not be able to insert the data until we add at least one partition. We have seen this earlier with respect to list partitioning. Same applies here. If you try to insert the data, it will just throw error. As we have successfully created the table, now it is time for us to understand how to manage the partitions for this table. Let's get into those details.